Hello, in this video I'm gonna explain to you how to code a simple application for OASIS, specifically on the EM60 board. And I'll first show you what this application actually does. I have here my terminal window already open, so it's a console or terminal application. There's a little help menu. It's really nothing much there. LED test, of course, whenever we are working with an embedded device. If you can get the LED to blink like this, then half the battle is won already. Hit any key to exit. So I did that just, and that's pretty much all this application does. So the point is just to show you the general application structure and how to code it. Let's move on to the application structure here. Let me get this into presentation mode here, just a moment. And here we go. Here we can see that OASIS applications are properly following a layer structure. And you will use API calls for anything you can. And then once you get to some higher level, you won't use APIs anymore, but replace it with your own code. So that way we end up with very well structured, consistently structured application. And that should simplify application development. When we look at these layers at the lowest level, of course, we have the hardware device drivers for things including the clock, timers, computer operating properly, or crash detection, analog to digital converter. General purpose IO DMA controller is important for acoustic data streaming. Comparator is part of one of the receiver options, memory protection unit, and the LEA, which is the DSP coprocessor. Building on that, some fundamental board functionality, power switch, and status LED. Actually, I haven't demonstrated the power switch yet. I'll get back to that here in a moment. And then on top of that can be acoustic data streaming here. That's generally how you do it for receiving acoustic data. It's a DMA operated ping pong buffer, DMA operated so that the processing load is not on the CPU. Then once the data is in the ping pong buffer, you go through some DSP processing using the DSP coprocessor that TI calls the LEA, low energy accelerator. You can do an FIR filter, or FFT is really a complex FFT, and we'll implement an IIR, infinite impulse response filter next, and add that to the next version of the API. Once that is done, you take your transformed or filtered data and you do some sort of analysis on it. Frequency hopping, pulse position coding would be one, acoustic communication protocol. There's other ones that we will add in future revisions of the API, or maybe you're doing signal detection. We're working on a project for whale detection, but it could be something else. Then on top of that, the choice of user interfaces. Here we're showing a console or command line application, but for machine interfacing, we'll implement one that's based on software registers that are controlled via dollar commands, as well as an option to actually connect a small OASIS receiver to an Argos reporting a satellite tag. And so then you can have global reporting going on in there. Let me exit out of this here. And I said I hadn't shown you yet how to operate the reset switch. I want to show that before we actually go to the code. I'm pressing the button now. And here it says power state. And here the LED blinked 10 times. Now here it says sleep. And then I can hit the button again. Now you see some green blinking here. Power state. And okay, it switched on again and we can do our stuff again. So how is this all coded? Here we'll now look at the code structure, starting with, and again, this is the template app, so you can use it as a starting point for your own console apps. We are here in main.cpp, and you'll notice that a lot of the time there isn't much you have to change on this code. Here in main.cpp, we have identification of the application itself. It always has a name. Here it's called EM60 console template, and you would modify that. This is the application start point for the bootloader. It never changes. It's always this function here. And an application valid indicator, really just a space holder. The bootloader knows if it has the value A, C, D, E in there. In our app, we're setting it to 0, and we'll leave it to the bootloader after a successful download where there has been no data loss or corruption to take care of that. Then in the main function itself, OASIS initialize, so hardware initialization, no need to change that here. Then there's the app initialize, and keep that in mind. We'll get to that, what's happening in there. It starts up the crash detector or COP, some logging here, and now you see the LED debug logging here, and we see the LED blinking that you just saw here. Then the application is announced that it's this console app. If there has been a crash of your app, it will print out what caused the crash. That can be helpful in some debugging scenarios. Here the power button is initialized. And then we are going into our main while loop, and the power state is explored, and depending on what the power state is, if it's off, then it just goes to disable execution. That's our sleep mode. But if it's in the on state here, this is the on state here, then we're going to app process. So keep that in mind. We have app process and app initialize up here, and app announce here. Initialize, announce, and process. So now we are going back to the next level here, base.cpp. Okay, what happens in app announce? It just prints the application name. In app initialize, we are selecting the communication port, serial communication port, setting it to 9600 baud. It's a USB port. This becomes our standard communication port for input, and here for print also as output. And here we are initializing the power button, right? And then finally, under app process, you're now going to really your application code. And this is an instantiation of a class. EM60 console is a class, and my EM60 console is the instantiation thereof. So let's take a look what's happening in there. Here's process EM60. This is where all that happens. So here's the process function, has a while loop in there. It checks for serial input, and it exits if either there has been an exit command in the serial input or the power button has been triggered. So let's take a look what actually happens as we're looking for serial data. Here a little announcement, and then we're in this while loop here waiting for some data, and if there's no data, then it just kind of spins in here. It checks if a power button has been triggered, which would cause an exit, But if a character has been received, it checks out which one it is, help or LED test or exit or rebooting. And that's it. So this is the whole structure. And so here, really at this level, is where you would normally do your own changes, keeping these lower levels that I just went over unchanged. Well, now you know how to code a simple application for OASIS, and thank you very much.